Hello everyone, in this video we are going to be looking at chapter 6.1, which is on algebraic fractions. More specifically, we are going to be looking at the simplification of algebraic fractions. And hence, that will also be the objective of this video, which is to help you learn how to simplify algebraic fractions. Before we begin, I would like us to watch this lesson video on how to simplify algebraic fractions first.
So, first of all, what are algebraic fractions? What do you think algebraic fractions are? Yes, algebraic fractions, as the word suggests, it is a fraction, just that instead of numbers, in the numerator and the denominator, we have algebraic expressions. Okay? So, for example, we can have y over 85. Okay? Things like that. Okay, we can also have negative ones, maybe negative 3x squared plus 7 over 6x plus 1. Okay, so these are just some examples of algebraic fractions. Okay, so we need to first know how do we simplify algebraic fractions. Okay, for example, if I have 12 over 3, what is the simplification of it? 12 over 3 simplified is 4, right? And how do we get 4? Because numerator and denominator, we can divide by 3. Agree? Okay, so we simplify by dividing in the numerator and the denominator by a common factor. Let's say 16 over 12. How do I simplify this fraction? What do I get? 4 over 3, right? Okay, because I can divide by 4 on both the numerator and the denominator. So I divide by 4, divide by 4, and I will get 4 over 3. So that is a simplified manner. So the same will actually apply when it comes to an algebraic fraction. So for example, if you were to take a look at practice now 1, if I have 8x to the power of 5y, divide by 12x cubed y to the power of 4. What are the common factors in both the numerator and the denominator? We look at the numbers component first. 8 and 12 was a common factor. Divide by 4, right? Okay. Then we look at the x component. How many x's are in common? 3 x's are in common, so that means x to the power of 3. Okay? Then what about y? How many y's are in common? 1. Okay? Because we always take the lesser one. Right? So, doing this division, 8 divided by 4 when I have x to the power of 5 divided by x cubed, I'm actually subtracting numbers away. Okay, so 5 minus 3, I will be left with 2x, so x squared. There will be no more y's in the numerator. Okay, so in the denominator, so I'll left with 2x squared in the numerator. In the denominator, 12 divided by 4 is 3. X is no more because I have already divided it away. Y to the power of 4 divided by y, I'm getting y cubed. So that is the simplest form when it comes to an algebraic fraction. Okay? To finish up part B also, the same idea. x. So it is recognized as a set. Okay, so you cannot open it up, you cannot expand it. Expand is going to be a difficult task also because it's a power of 3. Okay, so you need to see this as a set. So x minus y to the power of 3 and x minus y, how many of it are in common? 1 only. So I will get rid of just a single set of x minus y. Okay, and that will leave us with x squared, x minus y squared, and then in the denominator 3y cubed. That's all. Okay. Questions? Right. So with this, we're done with this part, a simple segment. Okay.
I hope that the previous lesson video has helped you to understand how do we go about simplifying an algebraic fraction. Now we are going to take a look at practice now 2, where the expression, or rather the algebraic fraction that is given to us is slightly more complicated and not as straightforward as what we saw earlier on. So taking a look at part A first, where we want to simplify h squared plus 7hk over 5hk. In order for us to simplify, we notice that in the numerator, we have the terms h squared plus 7hk. And then in the denominator, we have the term 5hk. We cannot individually decide what are the common factors, in the sense that we cannot look at just h squared with 5hk and then separately from this 7hk. We need to see the things in the numerator as a collective. Okay, so therefore, when in such cases, what we need to do is that we need to factorize accordingly in the numerator or the denominator first. So by observing the numerator, h squared plus 7hk, within the terms there are some common factors. And the common factor would be h. So we need to factorize out the h in the numerator to get h times h plus 7k. The denominator has nothing for us to factorize since it is only one term, hence we get 5hk in the denominator. Now that we have it expressed in this manner, we see that I can divide the entire expression in the numerator by h and then also by h in the denominator. So I will divide by h in the numerator and the denominator to get a simplified fraction of h plus 7k over 5k. Hence, this would be the answer for part A. We next take a look at part B. Part B, we have 15p over 10p squared minus 5p. So, similar to what we did in part A, we need to recognize that in the denominator, we have to factorize first, okay, before deciding what is it that we need to divide in the numerator and the denominator. So in the denominator, having 10p squared minus 5p, I factorize by extracting common factors to achieve 5p times 2p minus 1. Then from here, I notice that there is a common factor in the numerator and the denominator as a whole, which is 5p itself, because between 15 and 5, there's a common factor of 5, and between p and p, I have another common factor of p. 2p minus 1 has no common factor in the numerator. And therefore, upon simplification, I will get the answer of 3 over 2p minus 1. And that will be the answer for part B. Next, we take a look at part C in this practice now example. So in part C, we have z squared minus 4z over 4z minus 16. Applying the same principle, we need to factorize the numerator and the denominator separately first. So in the numerator, what we will get is z times z minus 4. That is by factorizing by extracting common factors. We apply the same method to the denominator, which is to get 4 times z minus 4. Now we can see very clearly the common factors between the numerator and the denominator, and that will be z minus 4, and hence we divide in the numerator and the denominator to get the answer of z over 4. So in these examples that I have shown via practice now 2, we observe that the fractions that are given to us all require some form of factorization either in the numerator or the denominator, otherwise both. However, in these expressions or these algebraic fractions that we have seen, the factorization method that we chose to employ is often in extracting common factors. We might need to think about whether is this always the case. Are there other methods of factorization that we already know? The answer to that is that there are times like this where we have these examples in practice now 3 to know that it is not all the time where we need to factorize by extracting common factors. We may need to do our algebraic identity. We may need to do quadratic factorization using cross method, or we need to do factorization by grouping. So that will be the focus in practice now 3. We first take a look at question 1a. We have 3v squared minus 9v over v squared minus 9. We first take a look at the numerator. In the numerator, 3v squared minus 9v has common factors between the terms, and that is 3v itself, so we get 3v times v minus 3. Then, in our denominator, v squared minus 9, I hope it rings a bell to you that it is v squared minus 3 squared. Hence, we can apply our a squared minus b squared factorization to get v plus 3 times v minus 3. Now that we have factorized it in this manner, we observe for common factors between the numerator and denominator to observe that there is a common factor of v minus 3 in both the numerator and denominator. Hence, we divide by v minus 3, and therefore our answer will be 3v over v plus 3. Let us now move on to take a look at part B. In part B, we have p squared minus away 7pq plus 12q squared over 5p squared minus 20pq. So, using the same principle of factorization, we see that in the numerator it is quadratic, so we need to do our cross method. So to do our cross method, it will look like this. We set up our table first to get p squared plus 12q squared minus 7pq. Then we think about the multiplication that will allow us to form and get this result. Then we do our cross and get negative 4pq with negative 3pq, for which they sum up to get this. Therefore, we have the minus sign here and minus sign here to get a positive over here. So therefore, my numerator will be factorized as p minus 4q times p minus 3q. Then in the denominator, we observe that we have to do factorization by extraction of common factors. That will actually be 5p times p minus 4q. Now that we have this, we observe that there is a common factor of p minus 4q in both the numerator and denominator. Therefore, we divide them in the numerator and denominator. Therefore, our final answer will be just p minus 3q in the numerator divided by 5p in the denominator. So that is our answer to question 1b. We finally take a look at part C, where we have x squared minus 3xy plus 2xz minus 6yz, followed by dividing with xy minus 2xz minus 3y squared plus 6yz. So observe that there are 4 terms in the numerator and the denominator. In order to factorize when there are 4 terms, we should intuitively think about factorization by grouping. So to factorize by grouping, we look for pairing. So in the numerator itself, we observe that there is a pair in x squared minus 3xy, for which we do our extraction of common factors to get this. Then we look at the next pair to get that we can factorize to get 2z times x minus 3y. We apply the same concept to the denominator. So in the first 2 terms, I will get this. and the next two terms, I will get this. This is not all when it comes to factorization. We need to factorize further, where we see that between the green and the orange in the numerator, there is a common factor of x minus 3y. And then in the denominator, between the green and the orange, I have y minus 2z as a common factor. So I will do the factorization to get x minus 3y times x plus 2z in the numerator. And in the denominator, I get y minus 2z times x minus 3y. Now that we have it expressed in this form, I will divide x minus 3y in both the numerator and denominator. And hence, we will get the answer of x plus 2z over y minus 2z. I hope that with these examples, you have a better understanding about the simplification of algebraic fractions. When we see each other again in our next lesson, I will consolidate everything and then also give you some additional questions for you to reinforce the concepts further. I'll see you in the next lesson. Bye bye.